Hi everybody, Miss Lorette here again. I'm going to continue walking you through a few Chapter 2 sections. So we're still reviewing sections 2.3 and 2.4, but today we're going to focus on multi-step equations that involve integers again, but also decimals. So you'll need something to write on and something to write with. And let's go ahead and get started. So I'm going to move to the next slide. Okay, so take a moment to copy these examples in your notebook. We're just going to do a quick review on how to work with decimals utilizing all operations here. And for my class, I've already mentioned to part of my class that when we do take the chapters 1 and 2 test, it is going to be no calculator, at least for parts of it. So when I do these, I'm going to be working through them without the use of a calculator. And I will admit, I worked out all of the problems from this slideshow ahead of time, so I am kind of following a bit of a script here just to ensure that I don't make any mistakes. So let's take a look at the first one. So we have 1.2 minus 8. So the 8 is technically a negative 8. I'm really just adding a negative 8 to 1.2. So I do want to subtract the two values because their signs are different. But when you add or subtract decimals, you might remember that you have to align the decimal points. Well, if 8 doesn't have a decimal, all I need to do is simply add 1. So when I do this without the use of a calculator, I'm going to subtract 1.2 from 8. So when I do this, I'm ignoring the signs and I'm just pretending 8's the bigger number and stacking it on top of 1.2. So again, when you add and subtract fractions, you have to line up those decimal points. So if a number doesn't have a decimal point, you simply add 1 and add a 0. Now I can actually subtract these values. I can't do 0 minus 2, so I'm going to have to borrow, make this a 10, subtract and get 8, and 7 minus 1 gives me 6, and the decimal point comes straight down. Now, before I write my final answer, I should go back to this original problem and ask myself, which number was further from 0, 1.2 or negative 8? Well, it's the negative, so I'm going to make my answer a negative 6.8. Okay, so that's my final answer there. Let's take a look at the next example. I have a couple double negatives. If you are familiar with the phrase keep, change, or keep, change, flip, I can simply change this to adding the opposite. Well, the opposite, if I add the opposite of a negative, that's going to be a positive. So again, if I'm adding or subtracting, I need to align my decimal points. So I'm going to take the 6.7 added with the 4.76, but if I'm missing a value here, I want to go in and add a 0. And now I can add down the columns. I should get 6, 14 carry the 1, 10 plus the 1 I carried should give me 11. And then I just bring my decimal point straight down into my answer. And again, you always want to go back to the original problem and ask yourself, what should the sign of my answer be? Well, if both of these ended up turning into positives that I was adding, my answer should remain a positive. Now let's take a look at some multiplication and division examples. Multiplication and division is a little different in that you don't really need to, or multiplication specifically, you don't really need to worry about the decimal points. You just kind of ignore them and stack the numbers as if they're integers. So when I'm looking at this, I'm looking at it as if it's just negative 8 times negative 655. Well, if I stacked them like this, and I am going to include my decimal here, but I'm looking at it as if it doesn't have one. If I stack them, the 6.55 or 655 would go up top, and then the 0.8 would go on the bottom. So when you're multiplying, you don't align the decimal points. When you're adding and subtracting, you do. Now I'm just going to go through and multiply this. 8 times 5 gives me 40, carry the 4. 8 times 5 gives me 40, plus the 4 I carried gives me 44, carry the 4. 8 times 6 gives me 48, and then plus the 4 that I carried gives me 52. Now I could go through for another row and multiply with all the zeros, but it's just going to give me zeros, so there's no point. So I'm going to call this done here. But before I write my final answer, I need to figure out where the decimal point goes. Well, I can't just pull it straight down because I got decimals in two different places. So when you're multiplying, because you don't align the decimals, what you do is you count up how many decimal places do you have. Well, I have 1, 2 decimal places in the first number, and then a decimal place in the other number. So if I count them all up, I should be accounting for 1, 2, 3 decimal places. Well, if I look at this number as it is, it looks like an integer. And in every integer, the decimal, we know, is currently all the way at the end on the right. I need to make sure that I adjust my decimal point by moving it 1, 2, 3 places to the left. So I should be getting 5.240. And since the zero is at the end, I don't really need to write that. And then I just double check my signs. Negative times negative leaves me with a positive, so I'm good with that sign. Okay, now let's take a look at the last one, 9.52 divided by negative 0.2. Well, if I'm doing it without a calculator, I gotta use long division. The first number goes in the house, as some people like to refer to it. It's our dividend. And the 0.2, I'm gonna ignore the sign for now and just write 0.2. And then I personally like to just adjust for my sign at the end. That's just my preference. Simply because when you're doing long division, you're multiplying and subtracting as you go, so I don't want to make any mistakes there. Now, the only adjustment we need to make here is I need to move the decimal point in my divisor to the right, however many times it takes until that number becomes an integer. Well, if I move it once to the right, it turns into a 2. But you have to follow the leader in the dividend. So if I moved it once to the right in my divisor, I gotta move it once to the right in my dividend. You may even wanna rewrite this. Now instead of 0.2, it's just a 2. And then the 9.52 turns into 95.2. And I can do my long division now. 2 goes into 9 4 times. I multiply and get my product. I subtract, get my difference. Bring any number that's still left down. 2 goes into 15 7 times. I multiply and get my product. I subtract and get my difference. The remaining number comes down. 2 goes into 12 6 times. And hopefully you know that's without a remainder. So now I've got my quotient. The decimal point, now that we've adjusted for it, it's just going to go straight up into our answer. So I know for my quotient, I should be getting 47.6, but you want to double check your signs. A positive divided by a negative should give us a negative. Okay, so this is a negative. So just a little bit of decimal review for you. Feel free to pause or rewind the video at any time if you need more time on certain topics. Otherwise, I am going to move to the next slide and keep going. And I've got to erase my board here. Okay, so we'll start off with hopefully a nice easy one, all integers here. If you wrote down those 4 steps from the last lesson, you should know that step 1 is to distribute when we see parentheses, which is what I'm going to do here. And again, you're not just distributing a 3, you're distributing a negative 3. So I'm going to copy down everything I haven't done anything with yet, and once I get to this parentheses, I'll multiply. I should get negative 3 for my first product, and a positive, because the 2 negatives cancel, a positive 24a for the second product. And then I just bring my minus 4a down. Notice that I don't distribute to that negative 4a because it was not in parentheses. Okay, step 2 is to combine any like terms. Well, I've got a variable term and a variable term that I can combine on the right, so I'm going to do that. And I should get a positive 20a. I have to subtract them because their signs are different, and I match the sign of the larger number, which was the 24. Okay, Step 3, if you have variables on both sides, collect them all to the same side by adding or subtracting. It doesn't matter which variable term you move. You can move the 20 to the left, or you can move the negative 3a to the right. I'm actually going to go with the latter, because if I move this negative 3a, I know that the opposite of a minus 3a is to do plus 3a. And the reason why I'm going to do this is because it's going to leave me with a nice positive term on the right. You can certainly subtract on the left, but you'll just want to remember when you do that, negative 3a minus 20a, their signs are the same. You have to add them together and make sure it stays a negative. So I say do what you feel comfortable with, just paying mind to your signs. Okay, so 20 plus 3a gives me 23a. Steps 1 through 3 are taken care of. Now I just have a 2-step to solve. I'm going to add the 3 first. I got to take care of what's not touching the variable before I take care of what is. I get 0 equals 23a. Divide by 23. And 0 divided by 23, I'm just going to carry my work over to the side here. 0 divided by any number is 0. And now a is by itself. Here is my final answer. 0 is a valid number on the number line. I have one solution here. Okay, now let's talk about some decimals. So again, I'm going to show you 2 methods to work with decimals, just as I showed you 2 methods to work with fractions. And again, choose the method that you find easiest. I'm going to do this problem the old-fashioned way, just working with the decimals. So I don't see parentheses, don't need to distribute, don't have any like terms, don't have, I do have variables on both sides, excuse me, so I do need to take care of that. So again, I can move the 5.7 over to the right or the 4.4 over to the left. Again, I'm going to do the latter because I can see that if I subtract the 4.4x to both sides, I'll still be left with a nice positive. Okay, so just a strategy to think about. And the reason I know to subtract this 4.4 and not add it, because that minus sign might throw some students off, if I look just to the left of this 4.4, there's no sign in front of it. Okay, when that's the case, a number is understood to be positive, so I would do the inverse and subtract it. Okay, so if I subtract 5.7 and 4.4, I'm going to get 1.3x. I'm going to bring down my minus 12.47 equals, and I still have a negative 6.1 on the right. Don't forget that that's a negative. At this point, it should just be a 2-step. So I'm going to add the 12.47 to get it to go away. I've got to take care of the addition subtraction before I can take care of multiplication division. What I do to one side, I do to the other. And again, I can stack these 2 numbers, making sure to align their decimal points, okay, because this is an addition subtraction. And if their signs are different, I got to take their difference and subtract them. And again, wherever you don't see a number on the right, you can just add a 0. I get my difference as 7, 3, and I look at this as just a 12 minus a 6, because if I borrowed a 1 from here, it's just going to turn that 2 into a 12 anyways. So that's going to give me 6, and my decimal goes straight down into my answer. So I've got 1.3x equals a positive 6.37, okay? Always make sure you're adjusting your sign if necessary. This should be positive because 12.47 is the larger number. And now to get rid of this 1.3, which is being multiplied, I divide. So off to the side here, I'm going to do a bit of long division. I may actually try and shrink this work a little bit so it's out of the way. So I'm going to put 6.37 in the house, 1.3 goes out the door. And again, as we saw, I have to adjust my divisor so it's an integer, follow the leader in the dividend. So this becomes 13 and 63.7. So a little bit of guess and checking might be in order to figure out, your quotients here. So when I'm looking at this, 13 and 63 Well, 13's pretty close to 12, and I know that 12 times 5 gives me 60. So let's see what 13 times 5 gives me. A little bit of guess and check. It's going to give me 15, carry the 1, 65, too big. So let's try 4. That's going to give me 12, carry the 1. 4 plus 1 is 5. Let's go with 4. I multiply and get 52, and then take their difference and get 11. Okay, so I have a number left over, so I have to bring that down. And now, when I look at this, I'm actually looking at the last values in each of these numbers, okay? Obviously, it's got to be something bigger than 5, because 5 won't get me to 117. It only gets me to 65. So when I'm looking at this, I'm thinking, what can I multiply with a 3 so that the last digit in my product is a 7? And when I think about that, I'm thinking, okay, well, 3 times 9 gives me 27. That ends in a 7. So let's try 9. Let's see what that gives us. 27, carry the 2. 9 times 1 gives me 9, plus the 2 I carried does indeed give me the 11 that I need. So I'm going to multiply, take my difference, which is 0, and my decimal comes straight up. So x should equal 4.9. And again, always go back and double check. Is it going to be a positive 4.9 or a negative 4.9? In this case, it would remain a positive because my signs were the same when I divided. Let's take a look at that same exact equation, but again, I'm going to show you the second method. You might look at that method and say, this really seems like too much work than it's worth. I'm comfortable working with the decimals. I'll stick to that method. And that's totally fine. It doesn't matter what method you choose. All I ask is that you give this new method a try until you make that decision. So this method involves kind of like clearing fractions. We're going to clear the decimals, but the first step is a little different, okay? Rather than multiplying everything by an LCD, you're going to multiply everything by a specific power of 10. To choose that specific power, whether it's 10, 100, 1,000, a million, hopefully not a million, but to choose that specific power, you're going to look at all of your decimals and you're going to look at the decimal that has the most decimal places and ask yourself, what is the furthest right decimal place? Well, when I look at the number that has the most decimal places, I'm looking at the negative 12.47. Well, if I look at the rightmost decimal place, the 7, what decimal place is that sitting in? Well, if I look at the 4, that's the 10th place. The 7 is in the 100th place. So what you do is you choose a power of 10 that is analogous to that decimal place. Well, the power of 10 that's analogous to the 10th place, or excuse me, the 100th place, it's the end of the day again, is 100. It is the end of the day, and I have decided I am not re-recording this lesson. I'm just going to keep going. Okay, so 7 is in the 100th place. I choose 100 as my power. So what I do, very similar to clearing fractions, is I multiply every single value in this equation by that power of 10. And you might be thinking, Miss Lorette, we're doing this without a calculator. That's going to take too long. There's a trick to multiplying decimals with powers of 10. All you do is you take the decimal point and you move it to the right however many times as you have zeros in that power of 10. I have 2 zeros in the number 100, so I'm going to move my decimal point 2 places to the right. Now be careful when you do this. When I look at this first number, do you see how I had to move it once and then twice? It kind of looks like it's encompassing the X here. Let me just do it off to the side. And this is obviously recommended if this is confusing to you, to do it off to the side. If I move the decimal point twice to the right, there's actually an empty space there. It's a little misleading because the X is sitting there, but there actually is an empty space there. When that happens, we have to add in a 0. Okay, so this isn't going to just be 5.7x, and it's not 57x, it's 570x, okay? I'm going to do the same thing with all the remaining decimals. Move that decimal point 2 places to the right. This is going to turn into 1,247. I'm going to do the same thing with 4.4. Again, the 4.4, if I move that 2 places to the right, I got to add a 0. So it becomes 440. And then 6.1 is a little easier to see here. I'm going to have to make that a 610. So again, you might be looking at these numbers thinking, Miss Lorette, these are huge numbers. This isn't any easier for me. It's actually more work. And my suggestion is the same. Choose what method you find is easiest. So if this is harder for you, don't do it. But I'm going to approach it the same way as last time. I've got variables on both sides. So I'm going to try and get them on one side. My 440x is positive, so I want to subtract it from both sides. And that is going to give me 130x. I bring down my minus 1247 equals negative 610. It's a two-step now, so I'm going to add. And over here, again, my signs are different, so I need to take their difference. So I'm going to take the bigger number, stack it on top of the smaller number, and subtract. I get 637. And I leave it positive because 1247 is larger. I bring down my 130x. It's a division step now, because that's the inverse of multiplication. And to get my answer, once again, I'm just going to do long division. 637 goes in the house. 130 goes at the door. And I can kind of cheat a little bit since we're doing the same problem again. But obviously, if you were doing this problem for the first time, you would be doing guess and checks again. But of course, we know that if I multiply it with 4 first, because we should be getting the same answer of 4.9, that's going to get me the closest that I can get to 637 without going over. So I'm going to put that over the 7, multiply to get my product, subtract to get my difference. And at this point, I have a remainder of 117, but no other numbers. So this is where you actually want to add a decimal point, bring it straight up into your quotient, add a 0, and bring that 0 down. So again, I know that if I sat and did a guess and check, a couple times, I would arrive to the fact that if I multiply with 9 times 1 gives me 9, plus the 2 gives me 11, I should get the correct product. So I'm going to put my 9 in my quotient, multiply, difference is 0, so that's my answer. And again, it should be a positive 4.9 because my signs were the same when I divided. So either method is perfectly fine. You make the choice of what's easiest for you. Sometimes clearing the decimals makes it harder, sometimes it makes it easier. Okay, so let's take a look at number 3. So careful with ones like this. I see parentheses, so I know my first step should be to distribute. If it's just a negative sign, there's really a negative 1 that you're distributing here. So I'm going to copy everything that was on the left, distribute and get a negative 7b, distribute again and get a negative 3. I don't have like terms anywhere, so I move on to step 3, which is to gather all of my terms that have a variable to one side by adding or subtracting. I'm just going to attempt to move the one that's on the right to the left. It's a negative, so I want to add it. They end up canceling out on the right. They also end up canceling out on the left. So what I end up getting is just a negative 6 on the left and a negative 3 on the right. And you should recall that from the last lesson, we reviewed that one type of answer you could get ends up resulting in a false statement. We have to write as our final answer, no solution. If it's a false statement, there's no solution, and you have to write that phrase as your final answer. If you stopped short of that and you just wrote negative 6 equals negative 3, you're not done. Let's take a look at one more, and of course it's going to be a decimal problem. Again, I'm going to clear the decimals here, and I encourage you to practice one more time clearing the decimals to get more familiar with that process in terms of just having an arsenal of strategies. So I'm looking at all of my decimals. They only have a tenths place in each of them. So the power of 10 that I want, that would be analogous to the tenths place, would be 10. Okay, if it was a tenths place, it would be 10. If you saw a decimal that had a hundredths place, it would be 100. If you saw a decimal that had a thousandths place, it would be 1,000. Okay, that's how I'm figuring out that power of 10. And just like last time, I'm going to multiply every single value in the equation, whether it be a decimal or an integer. I'm going to multiply every value by that power. And I can just use my shortcut. When I multiply, I just take all those decimals and move it one place to the right because I have 1 0 in the number 10. The 3.1 turns into a 31. The 1.9 turns into a 19. It also has a variable. The negative 1.9 turns into a negative 19b. And then the 3.1 turns into a 31. Okay, it's also important to note that just like in the last lesson, if you saw parentheses, you would need to make sure to distribute before clearing the decimals, the same way we had to distribute before we cleared fractions. Okay, you cannot, and I repeat, you cannot just clear fractions and decimals if you see parentheses in the equation first. You will make a mistake. You must distribute first. Okay, once I've taken care of all of that, I don't see any like terms, but I do see variables on both sides. I'm going to attempt to move the one on the left to the right by doing the opposite of a negative 19b and adding it. They cancel on the right, and they also cancel on the left. So I'm left with 31 equals 31, which is a true statement. So as I mentioned in the past, when this happens, when you get an answer like this, you're going to write one of three things. You can say all real numbers. You can say infinitely many solutions. Some textbooks might call it an identity, but you might see all real numbers and infinitely many solutions as the more common answers. Okay, but just like in a no solution equation, you have to have this phrase or one of the acceptable phrases as your final answer. And that is it. I hope you guys found this helpful. As is usual, please reach out to your math teacher if you have any questions, and feel free to pause and rewind this video as needed. Take care and good luck.